बिस्मिल्लाहिर्रहमानिर्रहीम। आज हम चैप्टर 2 का लेक्चर 2 पढ़ेंगे। लेक्चर नंबर 2 में हम एम्पलीट्यूड मॉड्यूलेशन के मुकम्मल कंसेप्ट्स के हवाले से पढ़ेंगे। इन दिस स्लाइड we can see that in the modulation process the voice, video or digital signal modifies another signal called the carrier. As we can see that voice, video or digital signal modifies what? Modifies carrier signal. तो जिस तरह हमारे पास हमारा वॉइस होगा या वीडियो होगी या डिजिटल कोई और सिग्नल होगा तो ये कैरियर सिग्नल को मॉडिफाई करेगा। In amplitude modulation, the information signal varies the amplitude of the carrier sine wave. You can see that most of the time our carrier signal is what? Sine wave. So, in amplitude modulation, the signal, the information signal, the original signal, the message signal, that will varies the amplitude of the carrier sine wave. The instantaneous value of the carrier amplitude changes in accordance with what? With the amplitude and frequency variation of the modulating signal. An imaginary line called the envelope connects the positive and negative peaks of the carrier waveform. And the next slide we will see that how can we develop the waveform. You can see here this is a sinusoidal modulating wave. It means that this is our original signal. Vm is the amplitude of this wave. You can see the maximum amplitude of this wave is Vm, and this signal we can refer as the information signal or the message signal. Let's see the next slide. In this slide we can see the envelope. Okay, this is I'll show you the envelope. This signal is actually an envelope, and you can see that VC tends to VC. It means in this portion VC is increasing, and then VC is decreasing, and then again. So you can see that inside the message signal, you can see this was the message signal, okay, this was the message signal. So if the amplitude of the message signal is increasing, so the carrier signal amplitude is increasing. If the amplitude of the message signal is going to decrease, then you can see the red line, the amplitude of the carrier signal is decreasing. Similarly, you can see the replica of the message signal, the other side. You can see this one. So you can see this is also the replica of the message signal. So whenever we are increasing the negative side, also the amplitude at the negative end is increasing of the carrier signal, and the amplitude of the message signal, when it decrease, then you can see this portion, the amplitude of the carrier signal is decreasing. We can see that this line is a reference line. You can see this one, this is a reference line. So the carrier peak is zero reference for modulating signal, and this is what AM wave, and you can see the up and the down, these two these are actually what? These are envelope. You can see this portion and this portion, this is an envelope. This kinds of way we call it is envelope. Okay, one thing, if the amplitude of the carrier signal is 0, it means let me change the color of the line. Wait a minute, let me change the color. If you can see here, this portion, as the amplitude of the carrier signal is 0, so you can see that we are getting unmodulated. Unmodulated means there is no modulation in this portion. From here to here, there is no modulation in this portion. You can see there is no modulation in this portion. But once the amplitude of the message signal is start increasing, then the amplitude of the carrier signal is also start increasing. You can see here is increasing, the negative side increasing, and then positive side increasing. You can see here, and so on. So if the amplitude of the message signal is increasing, the amplitude of the carrier signal is also increasing. और हमने ये कहा था कि अगर हमारे पास मैसेज सिग्नल जो है, मैसेज सिग्नल इंक्रीज़ होगा तो उसके मुताबिक हमारा कैरियर जो है वो इंक्रीज़ होगा. यानी कैरियर सिग्नल की चेंज जो है वो किसके साथ रिलेट करती है? मैसेज सिग्नल के साथ. तो ये है हमारे पास एम्पलीट्यूड मॉड्यूलेशन का कंसेप्ट. Okay, we will see all other details in the next slide. Let me check the next slide. In AM, it is particularly important that the peak value of the modulating signal be less than the peak value of the carrier signal. यहाँ ये बात बहुत ही ज़रूरी है कि मॉड्यूलेशन जो हमारे पास मॉड्यूलेटिंग सिग्नल का पीक वैल्यू है, यानी Vm जो है, दिस इज़ द पीक वैल्यू ऑफ मॉड्यूलेटिंग सिग्नल, ये हमेशा कैरियर सिग्नल के पीक वैल्यू से कम होगी. अच्छा, डिस्टॉर्शन occurs when the amplitude of the modulating signal is greater than the amplitude of the carrier signal. When distortion will occur? When the amplitude of the modulating signal is greater than the amplitude of the carrier signal. यानी अगर हम ये conditions satisfy नहीं करेंगे तो फिर क्या होगा? Distortion occur होगी. A modulator is a circuit. What is a modulator? A modulator is a circuit used to produce what? Amplitude modulation. Okay, this modulator is nothing but this is an electronic circuit which is used to produce what? Amplitude modulation. Amplitude modulators compute the product of the carrier and modulating signal. अच्छा, ये amplitude modulators ये क्या काम करता है? ये हमारे पास प्रोडक्ट होती है कैरियर सिग्नल की और मॉड्यूलेटिंग सिग्नल की. तो ये हमें याद रखना चाहिए कि हमारे पास जो मॉड्यूलेटर है वो क्या काम करता है असल में. अच्छा, इधर आप देखें, इस स्लाइड के अंदर हम देख रहे हैं कि ये हमारे पास है इंफॉर्मेशन सिग्नल or modulating signal, or we can say message signal. So the peak value of the message signal is what? Vm. तो इस मॉड्यूलेटर की इनपुट पे हम क्या दे रहे हैं? इंफॉर्मेशन सिग्नल दे रहे हैं. और फिर दूसरी साइड पे हम क्या दे रहे हैं? इधर हम इसको दे रहे हैं कैरियर. तो इन दोनों के मल्टीप्लिकेशन से हमारे पास क्या बनेगा? आउटपुट पे हमारे पास मॉड्यूलेटेड वेव बनेगा. तो ये अगर Vm है, ये Vc है, तो व्हाट इज V2? V2 इज इक्वल टू Vc साइन 2 पाई fc t प्लस Vm साइन 2 पाई fm t साइन 2 पाई fc इंटू t. ये है हमारे पास फाइनल जो ये है हमारे पास output expression for modulating signal. So amplitude modulator showing input and output signal. Modulation index in percentage of modulation. इधर आप देखिए AM waves showing peak Vmax. You can see here this is Vmax, यानी ये आप देख रहे हो, this is हम Vmax, and it starts from where? From the center point, to the peak, we call it as Vmax, and troughs, which is what? Vmin. You can see this is Vmax, and this is what? Vmin. You can see from here to here, this is Vmin. It means from the reference point to the first trough, this is called what? This is called Vmin, and from the reference point to the maximum, to the peak point, it shows Vmax. Okay, from peak to peak, Vmax peak to peak, and then Vmin peak to peak means from minimum to minimum, we call it as Vmin peak to peak, and this is Vmin peak to peak, and this is what? Vmax peak to peak. Okay, अच्छा, अब हम ये है हमारे पास एक मॉड्यूलेशन, मुकम्मल मॉड्यूलेशन की वेव फॉर्म है, और इस टाइप ऑफ वेव फॉर्म को हम कहते हैं एनवेलप। अभी हम नेक्स्ट स्लाइड की तरफ चलते हैं। इस स्लाइड में आप देखें मॉड्यूलेशन इंडेक्स और परसेंटेज ऑफ मॉड्यूलेशन। मॉड्यूलेशन इंडेक्स को हम m से डिनोट करते हैं। सो मॉड्यूलेशन इंडेक्स इज अ वैल्यू that describe the relationship between the amplitude of the modulating signal and the amplitude of the carrier signal. You can see this is a ratio of modulating the amplitude of the modulating signal and the amplitude of the carrier signal. So Vm divided by Vc, we call it is what? We call it is modulation index. We call it is modulation index. This index is known as the modulating factor or coefficient or the degree of modulation. It means that we will be getting this in some number, and it will show us the factor on which we can decide that either it is a good modulator or over modulating, or what types of a modulation is it. So on the basis of this modulation index we can decide. Multiplying the modulation index by 100, it will give us what? Percentage of modulation. So in this slide we are discussing about modulation index and percentage of modulation. So if we multiply this m with 100, it will give us percentage of modulation. Okay, let's go to the next slide. Percentage of modulation. The modulation index is commonly computed from the measurement taken on the composite modulated waveform using oscilloscope voltage values. अगर हम modulation index को या percentage of modulation को find करना चाहें, तो इधर देखिए modulation Vm हमारे पास, अगर हम oscilloscope पे देखें तो उधर एक हमारे पास वैल्यू होगी Vmax, और फिर दूसरी वैल्यू होगी Vmin. So Vmax minus Vmin divided by 2, it will give us what? Vm. It means that the peak of the modulating signal. The amount or depth of Am is then expressed as the percentage of modulation. It means 100 multiplied with m rather than as a fraction. So this way we can calculate percentage of modulation. Okay, you can see this slide. Now how to calculate modulation index from Vmax and Vmin from the graph. So you can see here, this is the figure from the oscilloscope, and you can see that we are getting here Vmax plus Vmax is equal to EC plus EM. What is EC? You can see this place, this is VC. You can see here this is EC, and where is EM? This is VM. You can see this one from this place to this place, this is what? EM. So EC plus EM is what? Vmax. It means that from the reference point, from this point to exactly this point, this is what? This is our Vmax. This is our what? Vmax. You can determine it from your own understanding. What is Vmin? So you can see here EC minus EM. This place EC. Where is EC? This is EC again, and this is EM. So the difference between EC and EM, so we will be getting what? V plus V min. So it means that this place to this place we are getting what? This is actually what? V min. Okay. What else? I think from this place to this place we will be getting V min. Otherwise, if you are getting the values, you can calculate and you will be getting plus V max and plus V min. Similarly, the other side you can see minus V min. Upper portion we are getting plus and then plus, and here we getting minus V min and minus V max. So here you can see minus V min is, this is plus EC and here is minus EC. This is minus EM and here is plus EM. Similarly, we will be changing the sign. So if here we are getting what? Plus EC plus EM. So for minus Vmax we are getting minus EC minus EM. So these are also the way to calculate modulation index, and you can see in the previous slide, you can see the previous slide that Vmax minus V min divided by V2, so we are getting what? VM. We are getting VM. Okay, how about the VC? How to calculate a VC? Okay, so you can see we will be getting the VC from is there any other value that we are getting the EC? Okay, so you can see here this one is the EC. You can see here this is the EC is here, so EC. Okay, so if we are getting EM divided by EC, multiply with 100, so we can get the modulation index and we can get the Vmax and Vmin from the formula is provided. Okay. Let me delete all the this, and then we will go to the next slide. We'll see. Okay, mathematically the modulation index is M modulation index, EM peak change in the amplitude output waveform, sum of the voltage from upper and lower side frequencies, and EC is the peak amplitude of the unmodulated carrier. So we can see that we are getting the modulation index from this formula, and the percentage of modulation index is EM divided by EC multiplied with 100, so we will be getting the percentage modulation from this formula. Okay, let's see the next slide. If the modulating signal is a pure single frequency sine wave and the process is symmetrical, then the modulation index can be derived as follows. We also can see here from the above figure that Em is equal to 1 over 2 Vmax minus Vmin, and Ec is equal to 1 over 2 Vmax plus Vmin. So we can get the modulation index as we said that Em divided by Ec. So you can just put the values from the above equation here. We will be getting this 2 and this 2 will cancel out. Vmax minus Vmin divided Vmax plus Vmin. So from this formula also we can calculate the modulation index. So again I am telling you that we can get the modulation index from this figure. You can see here from this figure we have Vmax plus Vmax plus Vmin minus Vmin minus Vmax, and then if we apply, so we can calculate it from this formula m is equal to, and we can get the modulation index from the oscilloscope value. Okay, next slide. Let's see the next slide. Since the peak change of the modulated output wave is the sum of the upper sideband frequency and lower sideband frequency, USF and LSF voltage, hence Em is equal to E upper side frequency plus E lower side frequency, where E USF is equal to E USF. Then if these two are same, it means if these are same, then E USF will be E LSF is equal to Em divided by 2, which is equal to 1 over 2 Vmax minus Vmin divided by 2, and we also can get, if 1 over 2 divided by 2, we can calculate 1 over 4 Vmax minus Vmin. So this way we can get E USF or E LSF. Okay, furthermore we can see here that overmodulation and distortion. When we can get the overmodulation and when we can get the distortion. So again you can see the modulation index should be a number between 0 and 1. Remember that we will be getting the modulation index between 0 and 1. Is you can see that the modulation index is actually the ratio of Vm divided by what? Vc. So the amplitude of the carrier wave is always greater than, or in extreme cases if these are equal, then only we will be getting Vm divided by Vc is equal to 1. So of course it can never ever be more than 1, and if the amplitude of Vm is 0, then of course we can get 0. So the modulation index, the value should be between 0 and 1. If the amplitude of the modulating voltage is higher than the carrier voltage, then M will be greater than 1. If the amplitude of the modulating voltage means Vm is higher than the carrier voltage, so M will be greater than 1. And if this is the case, it will never ever happen. But if this is the case that Vm is greater than Vc, then in that situation only distortion will occur. If this distortion is great enough, the intelligence signal become unintelligible. It means that we cannot get the original signal back, or we cannot get the message signal back. That will be something like a noise. Okay, Overmodulation and distortion. Furthermore, distortion of voice transmission produces garbled, harsh, or unnatural sound in the speaker. If there is a distortion, then we cannot get the original sound or the natural sounds. Distortion of video signal produces a scrambled and inaccurate picture on a TV. आपने देखा होगा कि टीवी में बाज़ औक़ात बहुत ज़्यादा ब्लर्ड किस्म की पिक्चर्स आती है, तो ये किसकी वजह से होती है? ये ओवर मॉड्यूलेशन की वजह से होती है या डिस्टॉर्शन की वजह से ये डिस्टॉर्शन क्रिएट होती है जिसकी वजह से। अच्छा, इसमें देखिए कॉजेज ऑफ ओवर मॉड्यूलेशन, ये आप देखें डिस्टॉर्शन ऑफ एनवेलप कॉज्ड बाय ओवर मॉड्यूलेशन। तो अगर ओवर मॉड्यूलेशन हो तो आप ये देखें कि इधर हमारे पास ये जो पोर्शन है ये तो अनवांटेड है, ये हमारे पास क्लिपिंग ऑफ नेगेटिव पीक्स अकर। So overmodulation where the modulating signal amplitude is greater than what? The carrier signal amplitude। तो अगर हमारे पास modulating signal के amplitude carrier signal से ज़्यादा हो तो हमारे पास क्या होगा? क्लिपिंग अकर होगी, ऊपर साइड पे भी क्लिपिंग होगी और इधर भी हमारे पास क्लिपिंग होगी, which is unwanted। So envelope is no longer the same shape as original modulating signal। अच्छा, side band and the frequency domain। So side frequency or side bands are generated as part of the modulating process and occurs in the frequency spectrum directly above and below the carrier frequency। We can discuss from this slide onward in the next lecture। Thank you so much।